The universe is supposed to be a place ruled by chance, by random collisions and slow drifting patterns that stretch across billions of years. Yet, every once in a while, something happens that seems so precise, so perfectly timed, that it feels almost staged. That is what happened when astronomers spotted the object now known as 3 Atlas, the third confirmed interstellar visitor to ever pass through our solar system. Its arrival alone would have been headline news, but what unsettled scientists and inspired endless speculation was not only what it was made of, but exactly when it appeared. In September of the year 2025, NASA announced one of the most important Martian discoveries to date. Using samples collected by the Perseverance rover in Jezero Crater, scientists reported evidence of strange leopard-spot patterns in mudstone that might represent traces of ancient microbial life. These were not vague stains or cracks, but mineral textures strongly suggestive of biology, the kind of biosignature that planetary scientists had dreamed of for decades. As the announcement spread across the world, another story was quietly developing in the sky. Just weeks earlier, on the 1st of July in the year 2025, the Atlas Telescope Network had detected something new entering the solar system. The object was traveling so quickly and on such a sharply hyperbolic path that astronomers knew instantly it had come from beyond our Sun's family of planets and comets. It was only the 3rd time humanity had ever seen such a visitor, following the famous Oumuamua in 2017 and Borisov in 2019. But unlike those earlier wanderers, this one seemed to have chosen a path that took it close to Mars. And it did so just as the world was buzzing with news about Martian biosignatures. The odds of such timing were astronomically small. Objects from interstellar space can come from any direction at any moment, and usually sweep past without ever being noticed. For one to be spotted only weeks after a major claim about Martian life, and then head toward a close flyby of the red planet, felt like a cosmic trick. Some astronomers admitted the coincidence gave them chills. Others dismissed the overlap as nothing more than the human brain's natural hunger for patterns. Either way, the sense of unease only deepened when the first chemical data arrived. The James Webb Space Telescope and other instruments reported that the visitor's coma, the glowing cloud of gas that surrounds its icy core, was not the usual mixture of water vapor and dust. Instead, it was dominated by carbon dioxide at a ratio to water of about 8:1. That was almost unheard of. Most comets are watery snowballs with only traces of other gases. This one looked like a frozen block of dry ice drifting in from another star. Carbon dioxide, of course, is the very gas that once kept Mars warmer and wetter billions of years ago, the very ingredient scientists dream of using to one day restore its thin atmosphere. And so the story wrote itself. Here was an interstellar object, full of the greenhouse gas Mars needs most, arriving at exactly the moment when we had just discovered hints of ancient Martian biology. The rational explanation said that all of this was coincidence, nothing more than the messy chaos of the cosmos. But the emotional response, even among sober scientists, was harder to silence. It felt too perfect, too arranged. As the comet approached from deep space, its trajectory revealed another curious detail. In early October, when it would be closest to Mars, the Sun would lie directly between Earth and the object. That meant, from our perspective, it would vanish into the solar glare, invisible to ground telescopes. For several crucial weeks, 3 Atlas would pass near Mars without our most powerful eyes being able to see. This natural alignment created a window of cosmic privacy, as if the universe itself was hiding whatever might occur. Scientists insisted that orbital mechanics offered the only explanation. Interstellar visitors have no control, no intention. They are ice and rock following the pull of gravity. Yet the story spread far beyond science journals. On social media, speculation exploded. Some claimed it was a probe. Others whispered about deliberate terraforming. NASA stayed cautious, repeating that all evidence pointed to a natural comet, unusual in chemistry, but not impossible. Still, the phrase that kept surfacing again and again was the same. Why now? The timing created an almost cinematic tension. On one side, the discovery of potential Martian life written in stone. On the other, an alien wanderer loaded with greenhouse gases, scheduled to brush past the red planet while Earth was forced to look away. If this were fiction, readers might dismiss the plot as too convenient, too contrived. Yet, it was unfolding in real time, and the world could only watch, or rather wait, as 3 Atlas drew closer to its fated encounter with Mars. On the first day of July, in the year 2025, the skywatchers of the Atlas network in Hawaii noticed a faint moving speck that did not belong. Atlas, which stands for Asteroid Terrestrial Impact Last Alert System, was built as a planetary guard, a chain of robotic telescopes sweeping the heavens every night in search of rocks that could threaten Earth. Its mission is simple: to find what could kill us before it arrives. But sometimes, while searching for danger close to home, it stumbles on mysteries born far beyond our sun. The object, at first, looked like a dim star that had slipped out of place. But the software that tracks motion revealed its true nature. It was moving too fast, on a path that was too sharply curved. Within hours, astronomers across the globe were running calculations, and the numbers told a startling story. This was not a body tied to the sun by gravity. Its orbit was hyperbolic, eccentricity greater than 1, which meant it had come from interstellar space, and once it left, it would never return. The announcement went out quickly, and the astronomical community felt the familiar rush of déjà vu. Only 2 times before had humanity confirmed such a visitor. In the year 2017, the strange cigar-shaped Oumuamua passed through, speeding away before we could understand its odd behavior. In the year 2019, the comet Borisov appeared, looking more ordinary, a dirty snowball like the comets of our own system. Now here was the third, 3 Atlas, another ghost from the stars. Right away, the chatter began. Was it more like Oumuamua, which had accelerated in ways we could not explain, or more like Borisov, comfortably familiar? The first observations were limited, a fuzzy glow surrounding a point of light. But already questions multiplied. The surveys showed a coma brighter in carbon dioxide than expected, an early hint that this one would not fit neatly into our categories. Still, at that moment in July, most astronomers were focused on its trajectory. 3 Atlas was not heading toward Earth, which brought a sigh of relief. Instead, it was on course to sweep through the inner solar system, skimming close to the orbit of Mars in early October. The timing was remarkable. Mars had already been the center of attention for weeks after NASA reported possible biosignatures in Jezero Crater. Now, the red planet seemed set to receive a silent visitor from another star, a comet full of unknown chemistry. Scientists are trained to be cautious, yet many could not help but feel the uncanny weight of coincidence. The public, too, was fascinated. News outlets compared it instantly with Oumuamua, sparking memories of debates about whether that earlier object might have been a probe. Social media lit up with theories, some playful, some serious, about aliens, about messages from the stars, about cosmic alignments. NASA moved quickly to calm the speculation. The agency explained that 3 Atlas showed no signs of artificial behavior, no sharp shapes, no strange accelerations, just a comet, albeit with unusual composition. The official stance was simple, unusual but natural. Yet people are rarely satisfied with plain explanations when the timing feels so deliberate. At observatories in Chile, South Africa, and Spain, teams rushed to capture as much light as possible from the faint intruder. They knew that once it swung behind the sun later in the year, it would be hidden from Earth for weeks. Every hour of data was precious. The trick was separating the faint signal of the comet from the noise of the atmosphere. Even with the best instruments, it was like trying to study a candle flame flickering on the horizon during a windy night. But slowly, the measurements built up, and the early hints of carbon dioxide dominance were confirmed. By mid-July, the object was officially catalogued as the third known interstellar visitor. For many, this was history repeating itself. For others, it was history accelerating. In less than a decade, humanity had gone from knowing of none to 3. Perhaps the galaxy was not so quiet after all. Perhaps the spaces between stars were filled with countless such wanderers, and only now were we developing the tools to notice them. Astronomers began to speak of the comet, almost like a character in a story. Unlike Oumuamua, it was no silent shard, and unlike Borisov, it was no ordinary snowball. It seemed to exist in between, carrying traits of both, natural yet peculiar. And its path, angled toward Mars during a moment of heightened planetary drama, gave it a sense of intention it surely did not possess. The universe does not plan, or so we tell ourselves. Yet, the arrival of 3 Atlas felt like a message written across the night sky, one we could not help but read. When scientists calculated the path of 3 Atlas, one fact stood out at once. Its orbit was hyperbolic. For most people, that word does not carry much meaning, but for astronomers, it changes everything. Nearly every object in our solar system is bound to the sun. Planets and asteroids follow ellipses, loops that bring them around again and again. Even long-period comets, the icy visitors that return only after thousands of years, are still connected to the sun's gravity. A hyperbolic orbit is different. It is the signature of something unbound, something passing through only once before vanishing into the dark. The discovery meant that 3 Atlas did not form here. It was born around another star system, flung into the void by gravitational forces long before humans even existed. It has traveled for millions, maybe billions, of years through interstellar space before chance brought it near our world. Its eccentricity, a measure of how stretched the orbit is, was greater than 1, a clear mathematical signal that the comet would not be captured. It came, it passed, and then it would leave forever. This made 3 Atlas only the 3rd interstellar object ever confirmed. The first was Oumuamua in the year 2017. That one was long and thin, tumbling like a shard, and it accelerated in ways no one fully explained. Some suggested it was pushed by outgassing. Others wondered if sunlight itself was giving it a gentle shove. A few even whispered that it might be an alien probe, a suggestion that launched endless debate. The second was Borisov in the year 2019, a much more familiar comet, its fuzzy tail and steady chemistry fitting well with expectations. Now came 3 Atlas, carrying the weight of comparison. At first glance, it looked closer to Borisov, a glowing coma surrounding an icy heart. But its trajectory placed it in a different category, and its chemistry soon added more questions. To the public, the main fact was clear enough. This was another messenger from the stars, and unlike Oumuamua or Borisov, its path would bring it near Mars. The word hyperbolic gave it an aura of mystery, as if it were a stranger who did not belong, cutting through our solar system with no plan to return. Astronomers tried to convey the wonder. Imagine, they said, throwing a ball high into the sky. If it falls back, it is bound, like planets and most comets. If you throw it with such force that it escapes Earth entirely, never to fall again, that is the hyperbolic case. 3 Atlas was that ball, hurled from a star system light years away. And in this rare moment, humanity had the chance to study it as it passed. The shape of its path also explained why no spacecraft could reach it. By the time we knew it existed, it was already racing too fast, tens of kilometers each second, too swift for any probe to catch. Our role would only be to observe from afar, to collect light and spectra, and to wonder what secrets its frozen body might hold. The feeling was bittersweet, a treasure chest drifting by that we could never open. Still, the hyperbolic nature made the discovery even more thrilling. It was proof that the galaxy is not empty between stars, but filled with wanderers, pieces of distant worlds cast out by chance. Each one is a fragment of a story we cannot fully read. Oumuamua, Borisov, and now 3 Atlas form the start of a catalogue that will grow as our telescopes improve. Perhaps in time, we will catch one early enough to send a mission, but for now, we are left with the stranger's brief visit. In the end, what set 3 Atlas apart was not only its speed and path, but the coincidence of its arrival. A hyperbolic comet from another star sweeping near Mars in the same year we announced possible traces of Martian life. Coincidence, perhaps, but to many it felt as if the universe had written the word connection across the heavens, even if science could not yet explain what that connection was. When the first light from 3 Atlas reached the James Webb Space Telescope, astronomers expected to see the familiar chemical fingerprint of a comet. For decades, the model of a comet had been clear, a dirty snowball of water ice mixed with dust and trace gases that release vapor when warmed by the sun. But 3 Atlas did not match that picture. Instead of a coma dominated by water, the spectrographs revealed a strange signature, a cloud where carbon dioxide was king. The ratio of carbon dioxide to water was 8:1, so far from normal that many thought the data was an error. Teams checked and rechecked their instruments. The results came back the same. 3 Atlas was exhaling carbon dioxide in amounts no one had ever seen before. For context, most comets contain mostly water ice, with carbon dioxide only as a secondary ingredient. Here, it was the other way around, as if the object had formed in a place where carbon dioxide froze, while water remained rare. This alone would have made the comet a unique laboratory, but the timing made the finding even more unsettling. Mars, the planet most associated with carbon dioxide, was about to be at the center of this story. Mars already has an atmosphere made almost entirely of carbon dioxide, but it is so thin that liquid water cannot survive on the surface. Billions of years ago, the atmosphere was thicker, warm enough for rivers and lakes. Scientists often speak of ways to restore that atmosphere, dreaming of a future where Mars is once again habitable. The most obvious gas to use is carbon dioxide, the very greenhouse blanket Mars already knows. And here was an interstellar comet, carrying more of it than any we had ever measured, heading toward a close approach with the red planet. Of course, no one suggested proof of intention. The laws of physics explain comet chemistry without resorting to design. A body forming near a carbon dioxide ice line in a distant star system could collect exactly this composition. Yet speculation bloomed. If someone wanted to send Mars a gift, a package of greenhouse gas to nudge it closer to habitability, it would look a lot like 3 Atlas. Scientists repeated the rational explanation, but outside the Academy, the whispers grew louder. Ground-based telescopes joined the study. SPHERIX, with its ability to capture infrared light across the sky, confirmed the strange readings. Carbon dioxide dominated, with hints of carbon monoxide and possibly cyanide compounds. Even a faint green glow was spotted in the coma, another clue that unusual chemistry was at work. Each new observation added another layer to the mystery, not lessening it. The idea of a comet that breathed carbon dioxide instead of water spread through media headlines and internet debates. For astronomers, the focus was still on the science. What could such chemistry tell us about how planets and comets form in other star systems? What conditions allow carbon dioxide to freeze in such bulk? Was 3 Atlas covered in a shell of dry ice, hiding deeper layers of water ice below? These were the practical questions, but the wider world latched onto a different one. Why did such an object appear now, just as the search for Martian life reached a turning point? The phrase whisper in carbon dioxide began to circulate, as if the comet itself carried a message. It was a poetic image, more than a scientific claim, but it captured the mood. A frozen wanderer from another sun arrives, exhaling the very gas Mars needs most, during the very season when humanity is debating Martian biosignatures. Coincidence or not, the universe seemed to be telling a story, and people could not resist reading meaning into it. The first time astronomers plotted the full path of 3 Atlas on their charts, they noticed something that made them pause. The object was not just sweeping through the inner solar system in some distant arc. Its track cut close to the orbit of Mars, far closer than anyone expected for such a rare interstellar visitor. It would not hit, but the geometry placed the red planet right in its crosshairs, a near pass measured in tens of millions of kilometers, small in cosmic terms. That alone was strange, but what made the moment even more striking was the timing. Mars was already in the spotlight after the discovery of possible biosignatures in Jezero Crater. Now, as if on cue, an interstellar comet rich in carbon dioxide was set to brush past it. The numbers were precise. On the 3rd day of October in the year 2025, 3 Atlas would make its closest approach, about 30 million kilometers from Mars. That is roughly 75 times the distance between Earth and the Moon. To the human imagination, it sounded like a near miss. To astronomers, it was close enough to matter, especially when the chemistry of the comet came into view. It was not just a rock or an icy fragment. It was a carrier of carbon dioxide in quantities no one had measured before. If Mars were a stage, the comet seemed to be arriving with the perfect prop. The coincidence grew sharper when the position of Earth was added to the picture. During the flyby, the Sun would stand directly between us and the comet. That meant ground telescopes would be blinded, unable to see what happened at the very moment of closest passage. For several weeks, the object would vanish from our eyes, hidden by solar glare. If one were writing fiction, it would feel too perfect, a setup designed for suspense. Yet these were only the cold mechanics of orbits, predictable and natural. Still, the pattern was hard to ignore. Mars has long been thought of as a place caught between life and lifelessness. Its thin carbon dioxide atmosphere preserves traces of a wetter past. Its rocks hold clues of possible ancient biology, and its dry surface invites dreams of restoration. The arrival of a comet carrying greenhouse gases at such a moment was enough to spark endless speculation. What if, some asked, this was more than chance? What if 3 Atlas was delivering what Mars once lost? A whisper of atmosphere, a taste of warmth. Scientists pushed back with careful explanations. A single comet, no matter how rich in volatiles, could not change a planet's climate. Even if all its gas were somehow poured into the Martian sky, it would vanish against the emptiness of space in little time. The scale was wrong, the physics unforgiving. Yet outside the language of equations, the symbolism remained powerful. For a public hungry for stories of life beyond Earth, the scene seemed written for them, a comet from another star passing Mars, while Earth looked the other way. Plans were quickly made to use orbiters already circling Mars. The European Space Agency prepared instruments on Mars Express and the Trace Gas Orbiter to capture whatever data they could during the flyby. If Earth could not see, perhaps Mars itself could. Scientists knew the chance to study an interstellar object so near another planet was once in a lifetime. Even the thinnest signals would be valuable. Each measurement, a piece of a puzzle about how such wanderers form and what role they may play in the galaxy. As the date drew closer, the tension grew. To the professional, the story was about data, about learning the truth of a rare comet's composition. To the public, it was about narrative, about Mars being singled out for cosmic attention. Whether coincidence or not, the red planet now felt like the target of a message written across space, with 3 Atlas as the courier. When Perseverance drilled into the layered rocks of Jezero Crater in the year 2024, scientists expected to find sediment that spoke of water, minerals shaped by ancient rivers, and perhaps faint traces of organics. What surprised them most were patterns that looked almost alive, spotted markings across the rock surface that resembled the hide of a leopard. These were not random stains. Under the rover's instruments, the spots showed a repeating structure, darker centers surrounded by lighter halos, a geometry that pointed to chemical reactions often linked to biology. They were not fossils in the sense of shells or bones, but they had the quiet suggestion of life written into mineral form. Back on Earth, the images stirred debate. To one side, they were nothing more than abiotic patterns, perhaps the result of water percolating through rock and depositing iron or manganese in circular clusters. To the other side, they hinted at something once alive, microbes that colonized wet mud billions of years ago, leaving behind traces of their metabolism. The argument was familiar. Science always works through doubt, but the visuals were striking. Even without training, anyone looking at the spotted textures felt the tug of recognition. They looked like something that had grown, not just something that had settled. The rover's cameras and spectrometers gave more detail. The spots were rich in carbon compounds, with ratios that suggested concentration rather than random scattering. On Earth, such patterns often form when microbes live in colonies, altering the chemistry around them. In salt flats, in shallow lakes, in volcanic springs, the same spotted signatures can be found today, preserved in stone as time hardens soft mud into rock. The fact that Jezero Crater was once a delta fed by rivers only added to the weight of the discovery. Where water and sediment meet, life on Earth flourishes. Could the same have been true on Mars in its warmer past? NASA was careful in its words. The agency described the features as possible biosignatures, not proof of life. Scientists know too well the sting of premature claims. In the year 1976, the Viking landers produced results that some thought showed biological activity, but later tests argued otherwise. Since then, the rule has been caution first, certainty only when no alternative remains. Still, the announcement in September of the year 2025 carried excitement. For the first time in decades, the case for past Martian life felt stronger than ever. Public reaction was swift. Headlines called the rocks Martian fossils, even though scientists resisted the word. Social media filled with images of the leopard spots, side by side with pictures of stromatolites on Earth, ancient microbial mats preserved in stone. The resemblance was close enough to feed the imagination. For ordinary people, the question was simple. If it looks like biology and smells like biology, why not call it life? For planetary scientists, the real importance lay in context. If the patterns were biological, they would mean Mars once hosted not just random molecules, but organized colonies. Microbes that lived together, shaped their environment, and left signatures still visible billions of years later. That would be more than a hint. It would be a statement that life is not rare, that where water flows and chemistry is rich, life finds a way. Even if the patterns turned out to be non-biological, they still marked regions where chemical energy was active, places where life could have taken root if it ever arose. The samples themselves are sealed and stored within Perseverance, waiting for a future mission to bring them back to Earth. Until then, the leopard spots remain an open question, a mystery in stone that cannot yet be settled. But their discovery changed the conversation. Before, Mars was seen as a world of what if. Now, it felt closer to a world of almost. The leap from almost to was is small, but it carries enormous meaning. The spotted rocks of Jezero are not yet proof, but they are a promise that the story of Mars and life may be even more complex than we once dared to believe. When scientists chose Jezero Crater as the landing site for Perseverance, they were not simply picking a place at random. They were choosing a library written in stone. Billions of years ago, a river flowed into the crater, spilling its load of silt and clay and creating a fan-shaped delta. On Earth, such deltas are known to preserve records of past environments with extraordinary detail. They trap organic matter, seal it within fine sediment, and guard it against erosion. For Mars, a planet that lost much of its atmosphere and surface water, these ancient deltas are like locked vaults, holding secrets of a time when life might have had a chance. When Perseverance began drilling cores from Jezero, the reasoning was simple. If life ever took hold on Mars, its traces would be safest here. On Earth, river deltas like those of the Nile or the Mississippi carry nutrients, support ecosystems, and layer year upon year of sediment that can be read like pages in a book. In Greenland and Canada, deltas billions of years old have revealed microbial textures still visible in stone. The Martian version, untouched for eons, offered the same possibility. The beauty of a delta is in its layering. Each flood lays down a sheet of silt. Each season deposits minerals, and over time the pile grows thicker, compressing and hardening. Every layer is a snapshot of conditions at the time it formed. To a geologist, these layers are as clear as tree rings to a botanist. They tell of wet periods and dry spells, of chemical shifts, of the rise and fall of ancient water levels. For Mars, reading those layers is like turning back the planet's clock to a time when its climate was not yet hostile. The rover's instruments confirmed that Jezero's delta was rich in clays, minerals that form only when water interacts with rock. Clays are excellent at trapping organics, their fine grains wrapping fragile molecules and protecting them against radiation and decay. On Earth, they preserve traces of amino acids and lipids for billions of years. To find them in Jezero was a sign that if Martian life ever existed, its fingerprints could still lie hidden in these sediments. Scientists spoke of the delta as an archive, not of human history, but of planetary history. Just as ancient libraries preserve words written by long-vanished civilizations, the layers of Jezero may preserve chemical words written by microbes, chemical syllables preserved in the language of minerals. The leopard-spot textures found in mudstone were one possible page, but the delta itself promised an entire book, a record written over centuries and millennia of flowing water. The rover could only scratch the surface. Its drills collected cores a few centimeters long, tiny compared to the massive layers stacked within the cliffs of the delta. Still, even those small samples carried immense promise. They would be sealed, stored, and one day, if missions succeed, returned to Earth for the most detailed analysis our laboratories can offer. For scientists, this is the holy grail of Mars exploration, not just pictures or surface tests, but actual rock in hand. The importance of the delta goes beyond Mars. If deltas on two worlds separated by millions of kilometers both act as keepers of biological memory, it suggests a universal truth. Wherever rivers flow into standing water, deltas form, and wherever deltas form, the possibility of life's record increases. That makes them targets, not just on Mars, but on exoplanets we may one day explore. They are natural filing cabinets of the cosmos, preserving evidence long after conditions change. Jezero Crater's delta is silent now, dry and windblown, its river gone for billions of years. Yet, within its walls lies a story still waiting to be read. Each layer, each mineral, each tiny inclusion may be a word from a chapter written when Mars was young. Perseverance is not just exploring rocks, it is opening an archive, and perhaps inside that archive lies proof that life once filled the red planet with its quiet presence. Today, Mars is a world of silence, its sky thin and weak, its air too fragile to hold warmth. The atmosphere is made almost entirely of carbon dioxide, yet it is less than 1% as dense as Earth's. That means, even at noon in summer, water cannot stay liquid on the surface. It either boils into vapor or freezes into ice. Billions of years ago, the story was different. Rivers carved channels, lakes pooled in craters, and evidence suggests that Mars once carried an atmosphere thick enough to keep it warm. What happened to that air, and what it would take to restore it, has become one of the great questions in planetary science. Scientists believe the atmosphere was stripped away by time. When Mars lost its magnetic field more than 4 billion years ago, the planet lost its shield against solar wind. Charged particles from the Sun swept through the upper air, slowly blowing it into space. Over millions of years, the planet's blanket thinned until only a wisp remained. This is why Mars, though once blue and active, is now red and dry. Its breath was stolen by the Sun. The question of how much atmosphere is left today has been studied closely. Orbiters have measured the composition and found mostly carbon dioxide, with traces of nitrogen and argon. Seasonal changes show that in winter, much of the gas freezes into dry ice at the poles, then sublimates again in spring. It is a fragile cycle, like a lung that cannot fill. To stand on the Martian surface is to feel almost nothing pressing on your skin, as if the air is barely there at all. For those who dream of human settlement, this presents the greatest obstacle: a planet with gravity close to Earth's, but an atmosphere too thin to breathe, too weak to protect against radiation or to support liquid water. Engineers have imagined ways to thicken it again. Ideas range from releasing carbon dioxide trapped in the soil, to melting the polar caps with orbital mirrors, to directing comets rich in gas to crash into the surface. Each idea speaks to the hope that Mars could one day regain its voice, to exhale a breath strong enough for life. The arrival of 3 Atlas made these discussions feel urgent. Here was a comet filled with carbon dioxide, approaching Mars at just the right time. Scientists knew a single comet could not transform a world, yet the symbolism was hard to ignore. The very gas Mars lacks was carried by a wanderer from beyond the stars, drifting close enough to stir the imagination. It was a reminder that nature already moves gases and ices around the galaxy, delivering ingredients across space without any help from us. If humanity could learn to capture such deliveries, perhaps entire atmospheres could be restored. The thought is daring, bordering on fantasy, but it echoes a truth. Atmospheres are not permanent. They can be lost, and they can be built again. Earth itself has seen vast changes in air over its history, from carbon dioxide, rich beginnings, to the oxygen-filled sky we breathe today. Mars, too, has shifted, and though its current state is thin and weak, it is not beyond the reach of change. For now, its breath is only a whisper. Dust storms raise the air in global swirls. Carbon dioxide frost forms and fades, and the thin atmosphere protects almost nothing. Yet even in that fragility, Mars teaches us something vital. A planet is not fixed. Its air is a living system, able to grow, able to collapse, and perhaps, one day, able to be revived. When we speak of breathing new life into Mars, we are speaking of giving back what it once had, of restoring a breath that has been waiting in silence for billions of years. The idea of changing Mars into a world more like Earth has long lived in both science and imagination. It is called terraforming, and while it may sound like science fiction, scientists have tried to calculate what it would take. The starting point is simple. Mars is too cold, too dry, and its atmosphere is far too thin. To change that, you would need to warm the planet, release trapped gases, and create a cycle that can hold on to air and water. The question is, how? One common idea is to use the carbon dioxide already locked in Martian soil and ice. If that gas could be released, it would thicken the atmosphere, trapping heat through the greenhouse effect. Studies show that polar caps hold enormous stores of frozen carbon dioxide, dry ice that comes and goes with the seasons. Some suggest melting the poles with giant space mirrors, focusing sunlight until the gas turns to vapor. Others imagine using nuclear devices deep underground to free buried reservoirs of gas. Even if these methods sound extreme, the basic principle is clear. The more carbon dioxide, the thicker and warmer the air. Another thought experiment involves importing material from beyond Mars. Comets are full of carbon dioxide, carbon monoxide, methane, and water, exactly the ingredients Mars lacks. Redirecting such icy bodies to strike the surface could deliver both heat and gases, starting a thicker atmosphere. The problem, of course, is scale. It would take hundreds, perhaps thousands, of large impacts to make a lasting change. The engineering needed to guide even one comet is far beyond our current reach. Still, the vision is powerful, a galaxy where worlds can be reshaped using tools already provided by nature. Scientists also consider more gradual approaches. Imagine factories on the Martian surface powered by nuclear or solar energy, designed to pump out greenhouse gases far stronger than carbon dioxide, compounds like perfluorocarbons that trap heat efficiently. Released in large enough amounts, they could warm the planet over centuries, thickening the air slowly but steadily. This would not be dramatic, no sudden breath of life, but a long, patient process of engineering climate. Of course, all these plans face limits. Mars has no magnetic field, and without one, solar wind continues to strip air from the upper atmosphere. Any attempt to build a new sky must also include ways to protect it. Some scientists have proposed placing a magnetic shield at a stable point between Mars and the Sun, creating an artificial field that could block the solar wind. It sounds far-fetched, yet the concept has been studied seriously, at least on paper. The arrival of 3 Atlas, carrying more carbon dioxide than any comet measured before, gave these thought experiments a strange context. Here was a real example of a delivery system already at work. An interstellar body, packed with greenhouse gas, flying close to Mars at just the right moment. It could not by itself terraform a planet, but it reminded everyone that in the universe, ingredients move naturally. Maybe the act of reshaping a world is not as alien as it seems, but part of a larger cycle, where comets and impacts already exchange gases across space. For humanity, the dream of walking under a blue Martian sky may remain far away, but thinking through the steps has value. It forces us to confront the physics of atmospheres, the fragility of climates, and the scale of engineering needed to change a world. It also makes us reflect on Earth, a planet whose atmosphere we are already altering without intention. Terraforming Mars is a thought experiment, but it is also a mirror, showing us how thin the line is between a living planet and a silent one. For as long as people have looked at the night sky, Mars has stood out. Its red glow was unlike the steady light of the stars. It moved, wandering against the constellations, and that restless nature gave it meaning. To the Babylonians, it was Nergal, a god of war and plague, fiery and dangerous. The Greeks saw it as Ares, and the Romans gave it the name that still endures, Mars, the bringer of war. Across cultures, the red planet became a mirror of human conflict, its colour tied to blood, to fire, to violence. Yet it was never only a symbol of destruction. In myth, it also carried hints of transformation, of change written in the heavens. When ancient storytellers described the motions of Mars, they were trying to make sense of its strange dance in the sky. Unlike most stars, it sometimes reversed direction, looping backward before continuing forward again. This retrograde motion puzzled observers, but also gave Mars a quality of unpredictability. To farmers and kings, such signs could not be ignored. Mars was treated as an omen, a warning that human events were connected to cosmic rhythms. Wars were launched, harvests feared, all because of the Red Wanderer's position in the night sky. Over time, Mars became linked not only to war, but also to masculinity, to iron, and to courage. In alchemy, it was the symbol of strength, marked by the circle and arrow that still represents the male sex today. Even as science advanced, the myths clung to the planet. When telescopes revealed its surface, the red deserts seemed to confirm its fiery legend. By the 19th century, some astronomers believed they saw canals, long straight lines that looked like works of intelligence. Suddenly, Mars shifted from the god of war to the home of possible civilizations. Writers seized the idea. H.G. Wells imagined Martians invading Earth in the War of the Worlds in the year 1898, bringing the myth of Mars into the Industrial Age. Edgar Rice Burroughs filled it with kingdoms and heroes in his Barsoom novels. In popular culture, Mars was no longer only a distant star of war, but also a stage for adventure, for life beyond Earth. The red planet carried both its ancient heritage and a new role, a canvas for human imagination. In the 20th century, as spaceflight became real, Mars took on yet another layer of myth. It became the next frontier, the place humanity might reach after the moon. Images from spacecraft showed a barren world, yet even then, the myths did not fade. Instead, they adapted. Mars became the symbol of possibility, of human resilience, of the dream to live on another world. It was no longer the god of war, but the test of our will to explore. The arrival of 3 Atlas reawakened these older stories. The timing felt uncanny. Just as scientists were announcing possible traces of ancient life in Martian rocks, a comet rich in carbon dioxide appeared on a path close to Mars. To some, it seemed like the planet itself was being written into a new myth, one that combined science and symbolism. Was Mars still the planet of war, or was it becoming the planet of rebirth? Myths evolve with time, and so too does our view of the heavens. What has remained constant is that Mars has always been more than a dot of light. It is a screen onto which humans project their fears, their hopes, their ambitions. In one age, it was an omen of battles. In another, it was the cradle of alien civilizations. And now, it is the possible second home of humanity. Science may strip away illusions, showing a dry and frozen desert, but myth continues to breathe meaning into the red planet. Mars is both real and symbolic, a place of rocks and dust, and at the same time, a vessel for stories that shape how we see ourselves. When astronomers traced the exact orbit of 3 Atlas, they noticed a detail that unsettled them. The comet would make its closest approach to Mars on the 3rd of October, in the year 2025. But from Earth's point of view, the Sun would be directly in the way. During that period, Mars and the comet would be hidden behind the glare of the Sun, impossible to observe from ground-based telescopes, or even most space observatories. It was a natural alignment, nothing more than geometry, yet the effect was dramatic. Just when the interstellar visitor would be nearest to the red planet, Earth would be blind. Solar conjunctions are well known to planetary scientists. They happen whenever Mars slips behind the Sun, blocking communication and observation for several weeks. NASA has long experience pausing rover commands during these times, waiting until the Sun's radio noise no longer scrambles signals. But to have an interstellar object pass so close to Mars during this exact window was uncanny. It felt as if the universe had timed a private meeting, arranging a ball-ticket rendezvous just out of human sight. For scientists, the frustration was immediate. They knew that close approaches are rare gifts. Every kilometer nearer means stronger signals, sharper data, better chances of capturing subtle details. To lose that opportunity to the glare of the sun was like being told a historic speech would be given. But you must listen from behind a closed door. They could calculate the path, predict the chemistry, but they could not watch the moment itself unfold. This blind spot fed the imagination of the public. Conspiracy theories spread across the internet, claiming that something was being hidden. In truth, nothing was hidden intentionally. The laws of orbits simply arranged events that way. But for many, coincidence looked like design. People asked why the comet could not have passed Mars at a time when we could see. Why, of all possible alignments, did the closest approach come during conjunction? Astronomers explained patiently that orbits are indifferent. 3 Atlas had travelled for millions of years through interstellar space. Its path was set by the tug of distant stars and the gravity of our Sun long before humans noticed it. There was no guiding hand, only physics. Yet the timing still felt scripted, and in that space between fact and feeling, stories grew. Some imagined that the comet was delivering something to Mars, shielded from Earth's eyes. Others suggested that the invisibility itself was the message, a reminder that not everything is meant to be witnessed. While Earth would be blind, Mars would not. Orbiters circling the red planet, like the European Space Agency's Mars Express and the Trace Gas Orbiter, were prepared to capture what they could. Their instruments were not designed for interstellar comets, but they might still record gas releases, dust trails, or strange chemistry as 3 Atlas swept past. Data from those spacecraft would trickle back only after conjunction ended, a delayed revelation that added to the suspense. The sense of a blind spot is powerful in human psychology. We fear what we cannot see. In this case, the fear was paired with awe. For weeks, as 3 Atlas brushed past Mars, the people of Earth would be forced into silence, staring at a sun that hid the very event they most wanted to watch. It was a reminder of the limits of our position in the cosmos. No matter how advanced our telescopes, there are still moments when geometry blinds us, when the universe arranges its own private scenes beyond our reach. Human beings are creatures of pattern. We see shapes in clouds, animals in constellations, faces in the grain of wood. This tendency helped our ancestors survive, teaching them to notice the rustle of leaves that meant a predator was near, or the change in seasons written in the sky. But the same gift can also mislead us, pushing us to connect dots that are not really connected. When 3 Atlas appeared, rich in carbon dioxide, and set to pass Mars just as biosignatures were being discussed, that instinct surged to the surface. The timing was too neat, the chemistry too suggestive. It felt like part of a plan, even when every calculation said it was coincidence. Astronomers, trained to filter out noise, reminded the public that rare things still happen naturally. The universe is full of random overlaps. Lightning can strike twice, dice can fall on the same number again, and comets can arrive during moments of human excitement without any hidden cause. Yet for many people, the explanation rang hollow. The human brain struggles with chance because chance does not tell a story. A comet from another star whispering carbon dioxide into space near Mars, just as scientists debate, Martian life feels like a story. Stories are what we are built to believe. History shows how powerful this drive can be. In the 17th century, the sudden appearance of comets was often tied to wars or disasters. In the 20th century, when Halley's Comet returned in 1910, rumours spread that its gases would poison the Earth. Even today, each unusual alignment in the sky can trigger theories of prophecy or doom. Patterns are comforting because they reduce chaos, turning random events into signs. They give us a sense that the universe is not indifferent, but intentional. With 3 Atlas, the patterns seemed obvious. Step 1. Evidence of possible life in Martian rocks. Step 2. A comet rich in the very gas Mars needs, passing close at just the right moment. Step 3. Earth blinded during conjunction, forced to look away. To many, the sequence felt scripted, like chapters in a cosmic play. Online forums filled with speculation. Was it an engineered delivery system? A seed for terraforming? A message from distant intelligence? The lack of visibility during the flyby only fueled the sense that something important was happening just out of reach. Scientists countered with data. They showed that interstellar comets must exist in huge numbers, drifting endlessly between stars. They pointed out that orbits and alignments are governed by gravity alone, not intention. They explained that coincidence is not evidence, that unusual does not mean artificial. But here lies the difficulty. Logic does not erase feeling. Even those who accepted the science still admitted that the timing was uncanny, that the pattern whispered louder than the facts. The deeper issue is not whether 3 Atlas was a delivery system, but why humans so quickly believed it might be. It is the same reason we find shapes in static, or hear voices in the hum of machines. Our brains are tuned to amplify signal from noise, even when the signal is not there. For survival, false positives are less dangerous than missed threats. For meaning, false patterns are more comforting than a universe that is silent. As the comet neared Mars, the tension between science and story grew sharper. The data said one thing, the patterns suggested another. In the end, what people saw depended less on telescopes than on the lenses of their own minds. Some saw only coincidence, others saw design, but both reactions revealed the same truth, that humans cannot look at the stars without weaving them into narratives. The sky may be noise, but we will always find patterns in it. When astronomers first turned their instruments toward 3 Atlas, the comet appeared as a faint smudge against the stars, a pale blur marked by a thin tail. But as it drew closer to the sun, something unexpected happened. The cloud of gas and dust surrounding its core began to shine with a faint emerald light. Photographs taken through large telescopes showed a green glow spreading through the coma, giving the comet an eerie and almost alive appearance. To the casual observer, it was beautiful. To scientists, it was a clue. Comets often glow in strange colors. Their light is not their own, but comes from sunlight striking the gases that boil off as they warm. Each molecule, when energized, emits light at particular wavelengths, like a signature written in color. For most comets, The glow is whitish or bluish, a blend of water vapor, carbon monoxide, and ionized gases. Green is less common, and when it appears, it usually points to a handful of exotic molecules. Chief among them are dicarbon and cyanogen, both fragile compounds that break apart quickly in sunlight. When these molecules are present, they can make a comet shine emerald for a time before fading again. 3. Atlas did not just glow faintly green. Its coma seemed saturated with it, the emerald hue visible even in amateur photographs with long exposures. That meant the gas was abundant, spilling off the surface in large amounts. Dicarbon, a molecule of 2 carbon atoms bonded together, was the most likely source. On Earth, it is rarely found free in nature because it reacts too quickly, but in the cold of space, it can survive inside ices. When sunlight hits, it fluoresces green, casting its glow across millions of kilometers of vapor. The sight inspired excitement, but also unease. Cyanogen, another possible contributor, has a similar spectral signature and is historically infamous. In 1910, when Halley's comet returned, astronomers detected cyanogen in its tail. Newspapers spread panic by claiming Earth would pass through a poisonous cloud. It was harmless in reality, too diffuse to affect life, but the association stuck. Now, more than a century later, people were again seeing green in the sky and whispering about danger. The internet filled with speculation that 3 Atlas carried toxins, that its flyby near Mars could seed or sterilize. Science explained calmly that the gas was thin beyond measure, deadly only in imagination, but the story of poison in the sky was too strong to vanish. For planetary scientists, the green glow had a different meaning. It confirmed that 3 Atlas was chemically unusual, another layer added to the puzzle already raised by its extreme carbon dioxide content. If it carried dicarbon in such volume, it hinted at an environment of origin, unlike that of most comets in our solar system. Perhaps it formed near a carbon-rich star, or in a disk of material shaped by conditions we do not often see. Each molecule was a breadcrumb, pointing back to a birthplace across the galaxy. The glow also reminded researchers of how fragile such objects are. Dicarbon and cyanogen are short-lived once exposed to sunlight. Their presence meant the comet's surface was active, venting fresh material into space as it warmed. That activity made the emerald coma flare brighter each day, a sign that the comet was alive in a chemical sense, reacting and changing as it raced toward perihelion. As word of the green glow spread, it became a symbol. Some saw it as a signal of life, others as a warning of death. In truth, it was only chemistry, but chemistry with perfect timing. A comet from another star, rich in strange gases, shining emerald as it approached Mars, arriving in a year when the search for life on that very planet was dominating headlines. The color was not just light, it was story, and stories are what humans cannot resist. The idea began quietly, almost as a joke in late-night conversations among scientists and enthusiasts. If you wanted to change Mars, if you wanted to breathe new life into a frozen desert, what would you send? The answer seemed obvious. You would send exactly what Mars had lost: carbon dioxide to thicken its air, volatile gases to trap warmth, organics to seed chemistry. You would send a comet. And when 3 Atlas appeared, carrying more carbon dioxide than any comet on record, passing close to Mars at just the right time, the thought experiment stopped feeling like a game and began to look like a possibility. The hypothesis was simple enough to state. Perhaps 3 Atlas was not an accident, but a delivery system. Perhaps somewhere in the galaxy, long ago or far away, someone understood how to guide icy bodies toward barren planets. Such comets could serve as seeds of atmospheres, giant capsules of greenhouse gas aimed to restore a thin sky. The idea did not require a spaceship or a beacon. The comet itself was the tool, drifting for eons until gravity delivered it to the right place. Scientists resisted the leap. They pointed out that the chemistry of 3 Atlas could be explained by natural processes. In some star systems, carbon dioxide freezes out more readily than water, leading to bodies rich in dry ice. The orbit of 3 Atlas showed no signs of control, only the cold mathematics of gravity. To call it engineered was to cross from science into speculation. Still, the timing was so strange that the hypothesis found traction, especially beyond the walls of academia. Online forums lit up with discussions of panspermia and terraforming. People mapped out imaginary civilizations who might scatter such comets through space, each one a gift waiting to fall on a silent world. Others suggested that the engineers were not aliens at all, but perhaps a lost branch of humanity, or even Martians themselves from a deep past when their world still lived. The comet became a mirror, reflecting whatever each imagination wanted to see. What gave the theory weight was not proof, but resonance. The match between problem and solution was almost poetic. Mars needs carbon dioxide. 3 Atlas is made of carbon dioxide. Mars is the planet closest to being habitable. 3 Atlas is passing right by it. Even skeptics admitted the coincidence had the shape of design, even if design was the wrong word. NASA tried to temper the discussion by explaining scale. A single comet cannot terraform a planet. Even if all its gas were released, it would be swallowed by the thin Martian air and lost to space within decades. Terraforming, if possible at all, would require countless comets, a project of cosmic proportions. Yet the image was irresistible. One comet may not change a planet, but it could change a story, and that is what was happening. As the flyby neared, the phrase terraformer hypothesis spread. News outlets picked it up, framing it as a question rather than a claim. Could 3 Atlas be a tool, an intentional seed, or was it just another frozen traveler? No evidence could settle the question, but the story had already grown larger than the data. For many, the comet was no longer just an object of rock and ice. It was a symbol of possibility, of the idea that worlds can be changed, that perhaps life itself is carried across the stars in packages disguised as accidents. When the news of 3 Atlas reached the public, the response divided almost instantly into 2 worlds. On one side was NASA, steady and calm, offering measured explanations. On the other side was the internet, restless and loud, spinning theories faster than facts could be shared. The gap between these 2 reactions became a story of its own, one that revealed as much about human psychology as it did about a comet drifting in space. NASA's official voice was careful. Press releases described 3 Atlas as an interstellar comet with an unusual chemical makeup, nothing more. Scientists explained that its orbit was hyperbolic, meaning it would pass once and never return. And that, while its carbon dioxide ratio was striking, there was no evidence of design. They stressed that nature produces surprises, and that this was another chance to study the diversity of comets in the galaxy. They spoke with the calm tone of experts who have learned to understate rather than exaggerate, mindful of past controversies where bold claims had backfired. But on the internet, the mood was very different. Social media platforms erupted with speculation, some light-hearted, others more serious. To many, the timing felt too perfect. Biosignatures in Martian rocks had just been announced, and now a comet packed with carbon dioxide was flying close to Mars during a window when Earth could not see. It was a sequence of events with the rhythm of a story, and stories thrive online. Hashtags trended, memes spread, and threads filled with talk of alien probes, terraforming packages, even secret missions hidden by the conjunction. The panic was not about danger. Unlike asteroid alerts, this was not framed as a threat to Earth. Instead, it was a panic of meaning, a rush to explain coincidence with intention. People posted theories about ancient Martians sending the comet to their future selves. Others claimed Earth's governments knew more than they were saying. Old tales of Nibiru and wandering planets resurfaced, folded into the conversation as if the myths had been waiting for a stage. NASA responded by repeating the basics. 3 Atlas is natural. Its chemistry is unusual, but within the range of what comets can contain. Its path is set by gravity, not guidance. There is no reason to think it is artificial. The words were clear, but in the noise of the internet, they sounded flat. Rational caution rarely competes well with dramatic speculation. A whisper of mystery carries further online than a page of data. What made the difference sharper was memory. Only a few years earlier, Oumuamua had passed through the solar system and sparked the same divide. Some researchers insisted it was simply an odd-shaped rock. Others entertained the possibility of something more. Books and interviews carried the debate into headlines, and the public remembered that lesson. If scientists had argued over Oumuamua, why not again with 3 Atlas? The internet, already primed, treated NASA's calm as a sign that something was being held back. In truth, NASA's caution was not silence, but responsibility. Science works slowly, weighing evidence, ruling out simpler explanations before embracing extraordinary ones. The internet thrives on speed, on leaps of imagination, on stories that can be shared in seconds. The comet itself was quiet, but the human response split into 2 voices, one steady, one chaotic. As 3 Atlas drew closer to Mars, the tension between those voices grew. NASA spoke of spectra and ratios. The internet spoke of messages and mysteries. The calm of one and the panic of the other created a strange duet, echoing across the months of its approach. In the end, the comet revealed as much about us as about itself, showing how humans confront the unknown, some with restraint, others with fire. While Earth braced for weeks of blindness during the solar conjunction, Mars itself would not be without eyes. Several orbiters already circled the red planet, and they became the guardians of knowledge during the flyby of 3 Atlas. Among them were the European Space Agency's Mars Express, still operating after more than 2 decades, and the Trace Gas Orbiter, built to sniff out faint chemical traces in the thin Martian sky. These spacecraft were not designed for studying interstellar comets, but in the absence of Earth's telescopes, they were the only witnesses we had. Scientists quickly drafted plans. Mars Express carried a powerful spectrometer capable of capturing the light scattered by gases. If 3 Atlas released unusual compounds as it neared the planet, Mars Express might detect them. The Trace Gas Orbiter, with its sensitivity to molecules like methane and carbon monoxide, could look for changes in the atmosphere that might result from cometary material passing nearby. These were long shots, because the comet would not collide with Mars or even brush its upper air. Still, a cloud of dust or gas could leave temporary fingerprints. Every possibility mattered. NASA's Mars Reconnaissance Orbiter, famous for its high-resolution camera, also joined the effort. Although primarily built to map terrain, it had instruments able to detect dust storms and ice clouds. Engineers hoped it might glimpse the faint trail of the comet or record how sunlight scattered through its coma. The odds of a clear detection were uncertain, but it was better than silence. In this way, Mars itself became a remote observatory, carrying our eyes closer to the encounter than Earth could manage. The coordination was delicate. During conjunction, direct communication with the orbiters would be risky, as the Sun's interference could scramble commands. Engineers uploaded instructions in advance, programming the spacecraft like stage actors, given their cues before the curtain rose. Once the Sun blocked our view, the orbiters would act on their own, gathering data silently, waiting until contact was restored weeks later to send back their stories. It was a strange feeling, like trusting distant machines to take notes during an event no human could attend. This plan carried suspense. Scientists knew the chances of dramatic discoveries were slim, yet the hope was alive. Imagine, they thought, if the orbiters recorded a burst of carbon dioxide or an unexpected organic molecule. Imagine if the comet's trail mixed with the Martian atmosphere in some detectable way. Even the faintest signal would carry weight, because it would come not from theory, but from direct witness. In the language of exploration, that is priceless. The orbiters themselves had long histories of resilience. Mars Express, launched in the year 2003, had survived countless technical issues and was still delivering valuable science. The Trace Gas Orbiter, newer and sharper, was already rewriting what we knew about Martian chemistry. Together, these veterans carried humanity's hopes of not missing the moment. Though the world watched from Earth in frustration, knowing we could see nothing, comfort came from the thought that Mars was not blind. This chapter of the story reminded everyone of the quiet strength of robotic explorers. While debates raged online about messages and mysteries, these machines circled in silence, loyal and precise, recording spectra and images according to scripts written weeks before. They did not care about panic or calm, they only cared about data. And when the conjunction ended, when Earth's line of sight was clear again, they would return their findings. The presence of the orbiters turned the flyby into a waiting game. Humanity had to accept delay, to live with not knowing in real time. In an age when news arrives instantly and answers are expected within seconds, the silence was almost unbearable. Yet, it was also a reminder of how space exploration has always been: patient, uncertain, filled with long pauses between question and answer. As Mars circled the Sun with its watchers in orbit, the world could only wait, wondering what those machines would see as 3 Atlas swept past. On the 3rd day of October in the year 2025, 3 Atlas reached the point of closest approach to Mars. From Earth, the event passed in silence, hidden behind the glare of the Sun. But in truth, the moment was not silent at all. Out in space, the comet was alive with motion. Its frozen surface, warmed by the growing heat of the Sun, vented gas in jets that flared into its coma. The gases spread in great arcs, glowing faintly green where dicarbon molecules caught sunlight. A thin tail stretched for millions of kilometers, swept back by the solar wind. And there, moving in its stately orbit, was Mars, turning slowly beneath the faint haze of atmosphere that remained. The separation was about 30 million kilometers, a distance that sounds vast, but in astronomical terms is close. For a few days, as comet and planet drew near, their spheres of influence overlapped. Dust grains released from 3 Atlas drifted across space, and some may have brushed into Mars's thin sky. Whether any molecules survived to mingle with the atmosphere was unknown, but the possibility made the flyby more than symbolic. In those days, Mars was not just a planet, and 3 Atlas not just a comet. They were participants in a cosmic encounter, 2 worlds crossing paths in the endless ballet of gravity. Back on Earth, astronomers could only imagine the scene. No telescope could pierce the wall of solar glare, and no live images came. The silence was heavy, filled with speculation. Scientists clung to orbital calculations, confident in the geometry, but the public turned to imagination. In online spaces, the flyby became legend before it was even observed. Some described it as a delivery, the comet dropping invisible seeds into Martian soil. Others imagined a missed catastrophe, as if Mars had just stepped aside from a collision that could have reshaped its future. The reality was quieter, but no less profound. 2 wanderers had passed, each carrying the weight of billions of years, each continuing on its separate journey after the encounter. For the orbiters circling Mars, the day had been prepared long before. They turned their instruments as planned, watching for changes in air chemistry, scanning for shifts in light. Perhaps they caught faint traces of carbon dioxide or cyanogen drifting past. Perhaps they recorded nothing at all but empty space. Those answers would not reach Earth until later, when the sun no longer blocked communication. Until then, the world waited, filling the gap with stories. The comet itself knew nothing of the attention. It did not carry intention, only momentum. It had been flung from another star system in some forgotten epoch, wandering in cold darkness for untold ages before passing through this patch of space. Its trajectory bent slightly as it brushed past the sun, but it remained unbound, destined to return to interstellar night. Mars, too, remained unchanged in the short term. Its thin carbon dioxide atmosphere still clung to its surface. Its dust storms still brewed in silence. Yet, in human minds, something shifted. The idea of Mars as a stage for encounters had been strengthened. The 3rd of October became a date marked by wonder more than data. The flyby was not an event of collisions or explosions, but one of perspective. Humanity could not see, but we knew it was happening, and that knowledge alone carried weight. Somewhere beyond our reach, a comet from another star and a planet of ancient rivers shared a fleeting moment, an alignment that would not repeat. And as the sun continued to block our eyes, Earth waited for the day when the orbiters would speak, and the silence of the flyby would finally give way to story. When contact with the Mars orbiters was restored after conjunction, engineers held their breath as streams of data began to flow back to Earth. Weeks of silence ended in a flood of numbers, spectra, and images. These spacecraft had been alone in their watch, circling Mars while the planet and the comet drifted through their closest approach. Now, at last, humanity could learn what they had seen. The first reports came from the Trace Gas Orbiter. Its instruments had scanned the thin Martian air for changes, measuring how sunlight passed through the atmosphere before and after the flyby. In the data, was a faint but noticeable rise in carbon dioxide concentrations at high altitude. The increase was small, barely above the background, but it was there, a thin fingerprint of passing material. Alongside it were hints of carbon monoxide and cyanogen, molecules that matched what telescopes on Earth had already suspected to be abundant in 3 Atlas. Whether these gases were truly cometary or just natural fluctuations in Mars's atmosphere could not yet be proven, but the timing was striking. Mars Express added its own piece to the puzzle. Its spectrometer had captured light scattering off a diffuse cloud trailing behind the planet. The signature suggested dust particles, possibly cometary grains, caught by Mars's gravity and drifting for days before dispersing. No images showed dramatic streaks across the sky, but the data implied that Mars had been brushed by a veil of dust, a reminder of how thin the line is between encounter and contact. The rover Perseverance, still at work on the surface, recorded no visible changes, but scientists noted that dust at high altitude would likely go unseen from the ground. The Mars Reconnaissance Orbiter provided the most tantalizing results. While scanning for atmospheric haze, one of its instruments caught brief glimmers of unusual light scattering high above the poles. These could have been ice crystals, or they could have been fine particles shed from the comet's coma. For days after the flyby, the signals faded, suggesting the material was temporary. Again, the data was subtle, nothing bold enough to claim discovery outright, but enough to keep the question alive. When the findings were presented, NASA emphasized caution. Nothing observed proved that the comet had deposited gases or dust on Mars. The atmosphere of the red planet is dynamic, with natural fluctuations that can mimic such signals. But scientists also admitted that the coincidences were hard to ignore. The rise in carbon dioxide, the faint cloud of dust, the temporary scattering near the poles, all arriving within days of 3 Atlas's closest pass. At the very least, the orbiters had recorded an atmosphere in flux during a moment when a comet from another star passed nearby. The public, however, did not wait for certainty. For many, the reports confirmed what they had suspected all along, that Mars had been touched by an alien wanderer. Headlines framed it as proof of a cometary delivery, a seeding event that added gases to a world already primed for speculation. Online, the data was treated not as subtle hints, but as revelation, fuel for the idea that the universe was playing a deliberate hand. Among scientists, the tone was more subdued, but even they could not hide a sense of awe. The idea that a comet born around another star might have left its trace on a neighboring planet was powerful, even if the evidence was thin. It connected Mars not only to Earth, but to the wider galaxy, tying its history to distant worlds we may never know. The orbiters had not captured drama, no images of glowing streaks or crashing fragments, but what they returned was perhaps more valuable. They showed that even quiet encounters can leave marks, that even at 30 million kilometers, a comet can whisper into a planet's sky. In the end, what the orbiters saw was not proof, but possibility, and possibility is often the spark that drives science forward. As 3 Atlas swept past Mars and continued on its path toward the inner solar system, astronomers expected it to brighten further, its gases flaring under the growing heat of the sun. Instead, something unexpected happened. The comet began to fade. What had been a vibrant green glow turned patchy, uneven, and then weaker with each passing day. Its tail thinned, its coma shrank, and within weeks it was nearly gone from view. Telescopes that had tracked it faithfully now struggled to find even a trace. For many watching, it seemed as if the comet had simply vanished. The phenomenon was not entirely without precedent. Comets are fragile, their icy surfaces layered with fractures. As they warm, pressure builds inside them, sometimes splitting them apart. Some comets break into pieces and disintegrate completely, leaving only faint dust trails behind. 3 Atlas appeared to be suffering such a fate. Its brilliant activity in the weeks before may have been the last gasp of a body cracking under stress. The sudden disappearance of its glow suggested that either the comet had fragmented into smaller pieces too faint to see, or that its outer layers had exhausted their volatile supply, leaving little to vent into space. Scientists debated the cause. Some pointed to its unusual chemistry. A comet dominated by carbon dioxide ice rather than water ice would behave differently under solar heating. Dry ice sublimates quickly and forcefully, producing dramatic jets, but also running out faster than water. 3 Atlas may have vented much of its material early, leaving little fuel to sustain its brightness. Others suggested a structural collapse, the comet's nucleus breaking apart into dust too thinly spread to reflect much sunlight. Whatever the mechanism, the effect was clear. By the time it should have been at its most spectacular, 3 Atlas was all but gone. Astronomers compared it to Oumuamua, which had also confounded expectations, refusing to grow a visible tail and instead behaving like a shard of rock. Each interstellar visitor so far had refused to follow the rules. Borisov had been the closest to ordinary, but even it had shown subtle differences from solar system comets. With 3 Atlas fading into near invisibility, the pattern continued. Interstellar wanderers were never what we thought they would be. The vanishing act only deepened the mystery. For those who believed in the terraformer hypothesis, the disappearance was almost theatrical. A comet arrives carrying vast stores of carbon dioxide, passes near Mars during a conjunction when Earth cannot see, leaves faint chemical traces in orbiter's data, and then dissolves as if erasing its own evidence. To scientists, these were coincidences layered on top of fragile physics. To the wider public, it looked like intent, like a performance designed to leave questions rather than answers. In truth, comets vanish more often than most people realize. They are not solid rocks, but fragile clumps of ice and dust, barely held together. The journey near the sun is usually their undoing. Yet, even knowing this, the case of 3 Atlas carried symbolic weight. It had arrived with fanfare, whispered in carbon dioxide, glowed green, brushed past Mars, and then disappeared into silence. The sequence had the shape of a story, and stories linger. By the time the sun released its grip and telescopes could search again, 3 Atlas was no longer the comet it had been. It was weaker, fragmented, reduced to a shadow of its earlier self. Some observers wondered if we would ever confirm whether its nucleus survived or if it had fully disintegrated into dust. Either way, the comet that had captured the world's imagination had ended its performance. The vanishing act was complete, leaving behind only data, speculation, and the unsettling sense that sometimes the universe writes endings more mysterious than fiction. When 3 Atlas emerged from behind the sun after perihelion, astronomers expected either one of 2 outcomes. It might return brighter, energized by its closest brush with heat, or it might vanish completely, destroyed by the forces that tear fragile comets apart. What they saw instead was something in between, and that was far stranger. The comet had survived, but it was not the same comet that had gone in. Telescopes detected a dim body trailing a faint and broken tail. The once vivid green glow was gone, replaced by a weak haze that shifted in unpredictable ways. Spectra, taken in the weeks that followed, revealed a change in chemistry. The strong carbon dioxide signal that had defined 3 Atlas before perihelion had weakened, replaced by unusual ratios of carbon monoxide and faint hints of hydrocarbons. This was not the expected evolution of a comet. It was as if its outer layers had burned away, revealing a different composition within. Some even suggested it was no longer a single body, but a cluster of fragments moving together, each venting different gases, their combined output blending into a confusing signal. The mystery was amplified by timing. For weeks before perihelion, speculation about the comet's role near Mars had filled headlines. Its fade into near invisibility during the closest approach only made the story grow. Now, as it reappeared, altered and diminished, the questions multiplied. Was this simply the natural fate of an interstellar object, or had something unusual occurred during its hidden passage behind the Sun? The lack of continuous data left a hole, and into that hole poured imagination. Some astronomers argued that the change was predictable once you considered the comet's unusual starting chemistry. A body made mostly of carbon dioxide would vent violently early, losing much of its mass before perihelion. The deeper layers might then reveal different ices, such as carbon monoxide or hydrocarbons, shifting the spectral signature. Fragmentation could explain the inconsistent brightness. In their view, 3 Atlas was still only a comet, behaving according to the fragile laws of frozen bodies in space. But even these explanations carried uncertainty. There was no clear model for an interstellar comet dominated by carbon dioxide, and every observation seemed to raise more questions than it settled. For the public, the reappearance was treated almost like a resurrection. The comet had died, or so it seemed, during conjunction, only to rise again with a new form. Online, this became a symbol, a story of transformation, a cosmic phoenix remade by the fire of the sun. Some tied it back to Mars, suggesting that whatever had been delivered there was now spent, leaving the comet hollow. Others saw in its altered chemistry a deliberate signature, a coded message written in gas ratios too precise to ignore. NASA tried again to bring the conversation back to Earth. Press conferences stressed that comets are fragile, that perihelion is a brutal test, and that unpredictable changes are common. They pointed to past examples of solar system comets that split, dimmed, or returned with new chemical profiles. Yet the fact that 3 Atlas was interstellar gave every detail a different weight. Unlike ordinary comets, this one carried the aura of the unknown, and each irregularity felt magnified. In the end, the post-perihelion comet remained a mystery. Its dimness made further observations harder, and its rapid motion carried it out of range. Scientists gathered as much data as they could, but the comet was slipping away, heading back into the deep dark between stars. What it left behind was not certainty, but suggestion, a reminder that the rarest visitors refused to behave in simple ways. 3 Atlas had entered as a carbon dioxide giant, faded, vanished, and returned with a new face. Whether that transformation was natural or something more will remain unanswered, a puzzle left for the ages. Long before telescopes or spacecraft, people looked up at the sky and made sense of it through stories. Comets in particular carried a heavy weight in myth. They appeared suddenly, often bright and dramatic, then faded without explanation. To ancient eyes, they seemed alive, unpredictable, and powerful. Across cultures, comets became signs from gods, warnings of change, or messages from worlds beyond. The arrival of 3 Atlas, with its strange glow and perfect timing, inevitably revived these older ways of thinking, reminding us that human imagination has always tied the sky to meaning. In Mesopotamia, comets were often seen as weapons hurled by the gods, flaming arrows that streaked across the heavens. Records on clay tablets describe them as omens of kings falling, cities destroyed, or wars about to begin. When scribes wrote of the sky splitting open and light pouring forth, they may well have been describing the sudden appearance of a comet like 3 Atlas. In China, detailed records span centuries, where comets were named broom stars for the way their tails swept the sky. Each shape had a meaning, whether it pointed to famine, rebellion, or prosperity. These records, more systematic than most, now serve modern historians as a chronicle of celestial events. Among the Greeks and Romans, comets became tied to the fates of leaders. The death of Julius Caesar was said to have been marked by a brilliant comet, interpreted as his soul rising to the heavens. In that moment, a comet was transformed from omen to symbol of immortality. The gods were no longer merely punishing, but also lifting chosen figures into the sky. This duality, comets as both threat and promise, is a theme that echoes through centuries. When viewed through these lenses, 3 Atlas fits seamlessly into an older pattern. It appeared when humanity was once again searching for meaning in the stars. Its green glow sparked talk of life. Its carbon dioxide hinted at atmospheres. Its pass by Mars carried the weight of coincidence. Just as ancient people once tied comets to kings, many now tied it to planetary futures, to questions of terraforming and survival. The internet, in its way, became the new temple wall, filled with inscriptions and interpretations. Where once priests or scribes declared omens, now hashtags and threads carried the roll forward. What makes these comparisons powerful is not just the similarity of reactions, but the continuity of human need. Across time, comets have been mirrors. They reflect our fears when they blaze unexpectedly. They reflect our hopes when they seem to align with a story. And they reflect our questions about whether the universe is chaos or order. For the ancients, the answer was divine will. For us, the answer is science. But the emotional core remains the same. The sudden arrival of an object from outside our world forces us to ask what it means, not just what it is. Modern scientists may bristle at these comparisons, insisting that comets are icy leftovers of planetary formation, governed by physics alone. Yet even in science, the echoes remain. We give comets names, we mark their passages as historic, we speak of them as visitors. The language itself betrays our ancient instincts. In that sense, the sky gods never truly left. They linger, reshaped, in the way we still treat the cosmos as a stage with roles and plots. 3 Atlas, in its brief arc across our awareness, awakened those older patterns. It reminded us that the stars have always carried stories, and that each generation layers new meaning on old lights. Whether as weapons of gods, souls of emperors, or carriers of alien gases, comets demand a story. And the story we choose tells us less about the comet and more about ourselves. When 3 Atlas began making headlines, it did not take long for old myths to resurface. Among them was the story of Nibiru, a supposed hidden planet that for decades has been tied to doomsday claims. Nibiru was said to be large and unseen, moving on a secret orbit that would one day bring it close to Earth with catastrophic results. Astronomers have long explained that no such planet exists, but the idea never disappeared. It thrived in books, on websites, and in countless videos. The sudden arrival of a comet from beyond the stars gave it new life, and 3 Atlas was quickly folded into the Nibiru story. The logic was simple, but compelling for those who wanted it to be true. Here was an object no one expected, rich in strange chemistry, aimed toward Mars during a conjunction when Earth could not watch. For some, this looked less like coincidence and more like confirmation of a hidden plan. Nibiru, they argued, had sent the comet as a harbinger, or perhaps 3 Atlas was itself a fragment of the mythical planet, finally crossing paths with our solar system. Astronomers pushed back with data. Nibiru, they explained, is a fabrication, while 3 Atlas is real, tracked by precise instruments, its orbit fully mapped. The comet is small, a few kilometers across at most, not a world. Its hyperbolic path shows it will not return, while a planet would remain bound to the sun. These facts should have been enough to quiet the story, but online, facts do not always win. The timing and mystery of 3 Atlas gave the Nibiru myth a new stage, and people who had not thought of it in years found themselves reading, sharing, and wondering again. Part of the appeal lies in how Nibiru stories work. They thrive on gaps, on what is unseen or unexplained. The conjunction created such a gap, as Earth lost sight of Mars during the comet's closest pass. Silence became fuel, a perfect space for imagination. If the orbiters were watching, then perhaps they were seeing something too strange to share. If NASA seemed calm, then perhaps they were hiding the truth. The absence of evidence was reinterpreted as evidence of concealment. This cycle is not new. In the early 2000s, predictions of Nibiru's arrival spread widely, tied to the Mayan calendar and the year 2012. Nothing happened, but the idea did not vanish. Instead, it adapted, reappearing whenever a new astronomical event captured public attention. A solar eclipse, a close asteroid, an unusual alignment, each became a hook to hang the story on. 3 Atlas, with its interstellar origin and its whisper of carbon dioxide, was irresistible to this pattern. Scientists sometimes grow frustrated at these myths, but they also reveal something deeper. People want the universe to be meaningful. A comet arriving at the right time feels like a sign, and Nibiru provides a ready-made script for interpreting that sign. Even if the myth is false, the emotional structure is real. It offers a way to frame uncertainty, to connect scattered events into a narrative. In a world that often feels chaotic, that is a powerful pull. By the end of the comet's passage, most astronomers had turned their focus back to data, to spectra, to faint dust trails. Online, though, Nibiru lived on, now entangled with the story of 3 Atlas. It did not matter that no planet had appeared. What mattered was that the myth had found fresh fuel, and like the comet itself, it had blazed briefly, leaving behind questions and echoes. The idea that life might travel through space has existed for more than a century, but each new comet brings it fresh attention. Known as panspermia, the theory suggests that planets and moons are not isolated in their biology, but connected by the exchange of material. A rock blasted from one world could carry microbes shielded within, surviving the journey through vacuum to land on another world. Comets, with their icy shells and chemical stores, are often imagined as couriers, carrying seeds of life between stars. With 3 Atlas, the panspermia dream returned in full force. From the moment its composition was revealed, rich in carbon dioxide and faint hydrocarbons, people began to speculate. Could a comet like this have delivered the building blocks of life to Earth billions of years ago? The question was not without precedent. Scientists have found amino acids in meteorites and complex organics in the tails of comets. Spacecraft like Rosetta, which studied Comet 67P, confirmed that these frozen bodies hold chemistry relevant to biology. If one comet in our system can hold such molecules, why not an interstellar comet like 3 Atlas? And if so, was it not possible that it carried something more? For believers in panspermia, the flyby near Mars was almost poetic. Here was a barren world that once held rivers and lakes, passed by a comet rich in gas, perhaps shedding dust grains into its thin atmosphere. Even a handful of organic molecules could, in theory, settle into Martian soil. The chance of those molecules sparking life was remote, but the symbolism was powerful. A wandering messenger from another star brushing against a planet long thought of as Earth's twin. The scene felt like a story written by nature itself. Scientists were more cautious. They noted that survival across interstellar distances would be extraordinarily difficult. Cosmic radiation bombards any exposed surface, breaking down complex molecules over millions of years. Even microbes, if they ever existed on such a comet, would face immense odds. Yet panspermia does not require certainty, only possibility. If even one particle survives, if even one protected cluster of molecules makes it to another world, then the theory holds. And the galaxy is vast, filled with trillions of comets and endless time. The reappearance of 3 Atlas after perihelion, dimmer and stranger than before, only added to the fascination. Some wondered whether the transformation was natural, or whether something hidden within had been released. A scientific explanation pointed to volatile chemistry, but for the public, the dream of panspermia gave the event a different meaning. Perhaps the comet was not fading, but giving away its gift, scattering seeds before slipping back into darkness. The dream carried weight because it changed perspective. If panspermia is real, then life is not a local accident, but part of a cosmic network. Earth is not the only stage, but one among many, a node in a chain of exchanges stretching across stars. It makes life feel less isolated, less fragile, more inevitable. And when framed this way, 3 Atlas was not just a comet. It was a symbol of connection, a reminder that what falls from the sky might also be what allows life to rise. NASA reminded the public that no evidence of living material had been found, that comets remain frozen chemistry, not carriers of creatures. Still, the idea was not dismissed. Science allows space for possibility, and panspermia, while unlikely, remains within that space. 3 Atlas simply reopened the door, not with proof, but with presence. It came from another star. It passed near a planet that once had oceans, and it left us asking questions that stretch far beyond data. The flyby of 3 Atlas did not only stir talk of alien engineers or panspermia, it also reopened an old and haunting question. What if civilizations had risen and fallen long before ours? Perhaps even within the solar system itself. The thought was not new. Writers and thinkers have long imagined lost cultures that left no trace. But the comet gave the idea a fresh stage. If 3 Atlas looked like a delivery system, rich in carbon dioxide and timed to sweep past Mars, could it not have been sent by a civilization that no longer exists, one erased by time but once capable of shaping worlds? Speculation quickly turned to Mars. The red planet has always held a special place in these discussions. Long before spacecraft showed us a barren surface, telescopes revealed shifting dark patches that some believed to be vegetation. In the late 19th century, Giovanni Schiaparelli's maps of Martian canals ignited decades of debate. Though later dismissed as optical illusions, they fed the belief that Mars had once been home to builders and engineers. In the 20th century, Viking landers showed nothing of the sort, only dust and rock. Yet dry river valleys, ancient lake beds, and mineral deposits told a quieter story. Mars had once been wet, and where water flows, the possibility of life lingers. The discovery of methane traces in the Martian atmosphere in the early 2000s renewed these hopes. Methane is unstable, meaning something must replenish it, whether geological or biological. While most scientists favor chemical reactions in the crust, the idea of past or even hidden life refuses to vanish. And when 3 Atlas brushed close by, carrying gases that could thicken an atmosphere, imaginations connected the dots. What if Mars had once had a civilization advanced enough to attempt self-rescue, launching comets or capturing icy bodies to restore their climate? If so, 3 Atlas might not be alien at all, but a remnant of Martian ingenuity. Others turned the speculation inward, toward Earth itself. Human history stretches back thousands of years, but planetary history stretches back billions. Civilizations leave traces, but erosion, tectonics, and time erase almost everything eventually. Some argued that if an industrial society had existed tens of millions of years ago, its ruins might have been swallowed by oceans or crushed into the mantle. What if comets like 3 Atlas were their message in a bottle, seeds of atmosphere or life flung outward before collapse? The idea remained fringe, but the comet's oddity made even unlikely stories sound possible. The debate highlighted a key tension between what is knowable and what is imagined. Archaeology and geology provide evidence of our past, but absence of evidence is not evidence of absence. The comet's uncanny timing fed a hunger for deeper meaning, and earlier, civilizations offered a narrative that filled the gap. Online forums lit with talk of Atlantis in the stars, of builders who moved comets like chess pieces, of lessons lost and warnings hidden in the sky. Scientists reminded the public that civilizations, if they had existed in deep time, would likely leave at least some detectable residue, artificial isotopes, odd mineral layers, or anomalous structures. None have been found. 3 Atlas's chemistry, while unusual, is still explainable within the physics of interstellar formation. Yet even cautious scientists admitted that asking such questions can be valuable. It stretches imagination. It makes us re-examine assumptions. It pushes us to look harder at Mars, at Earth's own record, at the strange visitors drifting through the solar system. The idea of earlier civilizations is less about proof than about possibility. It speaks to a fear that our story is not unique, that others may have risen and fallen before us, leaving only faint whispers in cosmic dust. 3 Atlas, with its fleeting glow and vanishing act became a canvas for these fears and hopes. Whether or not any past builders ever existed, the comet reminded us that the universe is old, far older than humanity. And in that vastness, the unknown is always larger than what we know. The story of 3 Atlas left many feeling as though the universe had scattered hints, like breadcrumbs on a trail, daring us to follow. The comet was not the first strange visitor, and it would not be the last. Astronomers looked back at the handful of interstellar objects we have seen, from Oumuamua to Borisov, and now to 3 Atlas, and began to wonder if each was not simply an isolated curiosity, but part of a larger pattern. Perhaps the galaxy was not empty and indifferent, but layered with subtle signs, fragments carrying chemistry, coincidences, and questions, left for those curious enough to notice. The idea of cosmic breadcrumbs is not one of proof, but of suggestion. Each interstellar object arrives unannounced, shows behavior that bends expectations, and then slips away before we can learn much. Oumuamua tumbled past with no clear coma, yet accelerated in a way that defied full explanation. Borisov was more comet-like, but still carried chemistry different from most we had seen. 3 Atlas added its own riddle, a body dominated by carbon dioxide, glowing green, passing near Mars, then vanishing into fragments. None of these on their own proves anything beyond natural diversity, but together they feel like notes in a song, incomplete yet hinting at melody. Some scientists embrace this perspective cautiously. They speak of selection bias, that perhaps we are only now beginning to see the range of interstellar debris, and each one feels unusual because our sample is small. Yet, even they admit that the timing and character of 3 Atlas stand out. It arrived just as biosignature studies on Mars had stirred hope, just as debates about terraforming had gained public imagination. It passed when Earth was blind during conjunction, leaving orbiters as the only witnesses. And then, as if by design, it vanished before the story could conclude. The shape of it all resembled narrative more than accident, and that resemblance alone was enough to make people talk of breadcrumbs. Online, the idea took root quickly. People mapped timelines of events, linking Oumuamua in 2017, Borisov in 2019, and 3 Atlas in 2025, suggesting a sequence rather than coincidence. Some speculated about a larger cycle, as if interstellar objects passed through at intervals, carrying clues about life, about planetary futures, even about civilizations long gone. Others spun the thought in a gentler direction, suggesting the breadcrumbs were not messages, but reminders, nudges that the universe is active, and that we are part of something larger than our small world. NASA's voice, as always, remained calm. Officials explained that interstellar objects are expected statistically, that billions of comets and asteroids wander the galaxy, and that the more we look, the more we will find. To them, these were not breadcrumbs, but debris, natural outcomes of planetary formation in other star systems. Yet the metaphor persisted because it spoke to something deeper than data. A breadcrumb trail implies purpose, that we are being led, that we are not alone in our search. It taps into myth as much as science, echoing old stories of journeys guided by signs. The strength of the idea lies not in evidence, but in imagination. Humanity has always sought patterns, even when nature offers none. 3 Atlas, with its sequence of mysteries, was almost too perfect a candidate. The comet asked more questions than it answered, and each unanswered question became a breadcrumb of its own. People are not satisfied with silence. They want to believe the trail leads somewhere, to another world, another mind, or at least another understanding of our place in the galaxy. Whether or not the trail is real may never be known. What matters is that 3 Atlas made us look differently at the sky, linking past visitors with present mysteries and wondering about the next. Each object, fleeting and strange, becomes a step along a path we cannot yet see. If they are breadcrumbs, then the universe is inviting us onward. If they are only chance, then the invitation is no less powerful, because meaning is what we bring to the journey. When 3 Atlas first appeared in the night sky, it was science that gave us the numbers. Astronomers calculated its orbit, confirmed its interstellar origin, measured its spectrum, and identified carbon dioxide as its dominant ice. Telescopes traced its tail, noted its green glow, and followed it as it approached Mars. Every detail was precise, grounded in mathematics, and placed neatly into data tables. But outside the labs and observatories, people did not speak in the language of ratios and coordinates. They spoke in stories. A comet glowing green was not simply sublimating carbon, it was a messenger. A pass near Mars was not just geometry, it was fate. And when the comet vanished after perihelion, the absence of light was not physics, it was performance. This divide between what science says and what people feel has always been with us. Science builds with evidence, slow and careful, layering each conclusion on tested results. Storytelling builds with symbols, fast and imaginative, connecting events into meaning, even when evidence is thin. Both are powerful, but when they collide, as they did with 3 Atlas, the tension can be sharp. NASA and other agencies repeated that the comet was natural, its behavior explainable, its chemistry unusual but not impossible. Yet the internet, filled with myths of terraforming packages, alien seeds, Martian civilizations, and cosmic breadcrumbs. The same event gave birth to 2 realities, one of data, the other of narrative. The truth is that people need both. Science explains how, but storytelling asks why, and humans are creatures of why. A green comet, arriving just as we debate Mars's habitability, is coincidence in the lab, but destiny in the mind. A faint rise in carbon dioxide in the Martian atmosphere is a fluctuation in the data, but a signature in a story. We may know better, yet we cannot resist the urge to weave meaning into chance. Even scientists do it, though they dress it in cautious language, speaking of significance, anomalies, and implications. At its heart, science too is a form of storytelling, only with stricter rules and slower pacing. The clash became especially visible during the weeks of conjunction. Earth could not see Mars, and the orbiters were programmed to watch in silence. For the scientific community, this was routine. Data gaps happen, and patient analysis is part of the work. For the public, it was unbearable. Silence was not just a lack of information, it was a blank page waiting to be filled. And fill it they did, with theories of hidden discoveries, with comparisons to Oumuamua, with whispers of secrecy. When the orbiters finally returned their results, subtle and inconclusive, science called it progress, but the public called it mystery. It is tempting to view this as a failure, as if storytelling only distracts from truth. But that is not entirely fair. Storytelling also fuels curiosity. Many of those who first read about comets as omens or signs later became the scientists who studied them. The myths of the past led to the observations of the present. The excitement around 3 Atlas, whether grounded in science or not, brought people to look up, to care about spectra, to debate the chemistry of Mars's atmosphere. Without the story, the science might have passed quietly. The danger lies in balance. When story overwhelms science, belief can harden into conspiracy and curiosity turns to fear. When science dismisses story too sharply, it alienates those who are only trying to make sense of wonder. The task, then, is not to silence one side, but to bridge them. To say yes, the comet's chemistry is fascinating. And yes, people have always seen meaning in comets. And yes, the truth is likely natural. But the mystery of nature is no less inspiring than any myth. 3 Atlas showed us this balance in real time. To scientists, it was an object from another star, fragile, volatile, and short-lived. To the wider world, it was a chapter in a larger cosmic drama. Neither view is wrong, though one is testable and the other is not. What matters is that together, they remind us of the 2 ways humans engage the unknown. We measure and we imagine. We calculate and we narrate. The comet was ice and dust, but also story and symbol. It was a scientific puzzle and a myth reborn in the digital age. In the end, science will archive the data, publish the papers, and move on to the next object. Storytelling will linger, reshaping the comet into legend, recalling the year when a green visitor brushed Mars and then disappeared. Both will survive, because both are part of how we understand the universe. Science gives us truth, storytelling gives us meaning, and the sky will always provide material for both. 3 Atlas forced humanity into a space that is never comfortable, the space of not knowing. It gave us data that was strange but not impossible, coincidences that looked like intention but might have been random, and signals faint enough to be read either as proof or as noise. This was not the first time science had faced such ambiguity, but it was one of the most public. For months, headlines shouted about alien probes, terraforming seeds, and secret missions, while scientists repeated the words natural, likely, and inconclusive. The gap between those 2 voices was not just about evidence, it was about how humans handle uncertainty. Ambiguity is the hardest test because it demands patience, and patience is scarce. Our minds are designed to see patterns quickly, to connect dots even when no line exists, because in the deep past, it was safer to assume the rustle in the grass was a predator than to wait for proof. That instinct lives on, shaping how people react to events, like the passing of an interstellar comet. A green glow becomes a message. A flyby near Mars becomes a plan. A vanishing act becomes a performance. The leap is fast, and once taken, it is hard to pull back. For scientists, the rules are different. Ambiguity must be faced slowly, weighed against models, checked against controls, and compared with past cases. This method produces truth, but rarely speed, and in an age of instant information, that slowness feels unbearable. When 3 Atlas disappeared after perihelion, NASA's cautious updates landed flat, while the internet exploded with certainty, each group sure their version was right. Ambiguity had given everyone a mirror, and each saw only what they wanted to see. The test of ambiguity is not just about comets. It is about how we live in a world that often refuses to give simple answers. A faint methane reading on Mars can be chemistry or biology. A signal from space can be interference or intelligence. A green comet can be natural or engineered. Each case forces us to hold both possibilities in mind, resisting the urge to collapse into one too early. Few people enjoy this balance, Yet, it is the only honest place to stand. 3 Atlas revealed how difficult this balance truly is. For some, the comet became proof of panspermia, or of lost civilizations, or of cosmic breadcrumbs left for us to follow. For others, it is dismissed too quickly, labeled ordinary, and filed away before its oddities could even be studied. Both reactions avoid the hard work of ambiguity. One rushes to meaning, the other rushes to closure. The test lies in resisting both, in keeping the question open long enough to learn. The orbiters around Mars, in their quiet way, modelled this patience. They collected spectra without judgment, recorded faint rises in carbon dioxide, noted odd scattering near the poles, and stored the data for later. When the results reached Earth, they did not declare certainty, they declared possibility. Something happened, they said, but whether it was cometary or Martian or statistical is not yet clear. It was a reminder that machines do not panic at ambiguity. They simply record. It is humans who struggle, humans who want the story to be finished before the data is even in. The lesson of 3 Atlas may be less about what it was, and more about how we reacted. Ambiguity revealed our need for narrative, our hunger for certainty, and our discomfort with silence. It showed the split between those who demand immediate meaning and those who insist on slow caution. And it asked us whether we are capable of living in the middle, of admitting we do not know yet, of accepting that mystery is sometimes the truest description available. In the end, the comet itself moved on, untroubled by our debates. It was ice and dust, fragmenting in sunlight, drifting back into the deep dark between stars. The test of ambiguity was not its burden, but ours, and whether we passed or failed remains unclear. What is certain is that the next interstellar visitor will arrive, and once again we will face the same challenge. Will we rush to declare, or will we learn to wait, to let ambiguity shape us into better thinkers rather than louder guessers? That is the lasting question left behind by 3 Atlas, a test that continues long after its light has faded from the sky. The idea of terraforming has always lived more in imagination than in engineering. It is easy to picture Mars with blue oceans and drifting clouds, but far harder to calculate the energy and time required to make such visions real. When 3 Atlas passed near Mars, rich in carbon dioxide and glowing green, the dream caught fire again, not because the comet could realistically transform a planet, but because it reminded us of what we long to see. Terraforming, in that moment, was less a technical plan and more a story we told ourselves, a way of imagining a future where barren landscapes bloom. The numbers are daunting. To thicken Mars's atmosphere enough to warm, it would require releasing more gas than all the comets we could ever hope to redirect. Even if 3 Atlas had struck Mars directly, its contents would barely scratch the surface of what is needed. Dust would settle, gases would escape into space, and the planet would remain cold. Yet the mind does not dwell on such limits. Instead, it leaps ahead, imagining the red planet wrapped in clouds, green valleys forming where craters once lay, and rivers running once again. 3 Atlas became a symbol of possibility, a reminder that the distance between dream and reality is bridged not only by technology, but by belief. Terraforming in our minds is powerful because it touches something deeper than science. It speaks to survival and to destiny. Humanity has always reshaped its environment, carving rivers, building cities, altering climates unintentionally or deliberately. To think about Mars is to extend that instinct to a new world. When we say terraform, we are not only describing a process of warming and thickening air, we are describing a continuation of ourselves. We imagine futures where children are born under an alien sky, but call it home, where plants grown in red soil feed generations, where humanity proves it can carry life beyond Earth. 3 Atlas arrived at just the right time to fuel this mental terraforming. Its composition read like a list of missing ingredients: carbon dioxide to trap heat, dust that could alter the thin atmosphere, perhaps organics that could feed chemistry. It passed close enough to Mars that for a moment the possibility seemed tangible. What if the universe itself had a hand in terraforming? What if comets were nature's way of nudging barren worlds toward habitability? Even if science dismissed it as coincidence, the story lingered because it satisfied the human need to imagine intention in randomness. In many ways, terraforming Mars has already happened, not in reality, but in culture. Countless books, films, and games have shown it transformed, with forests under domes, seas filling craters, or entire atmospheres revived by machines. Each version is different, but the pattern is the same: a world reshaped into something livable. This cultural terraforming may be more influential than any engineering study because it sets expectations. It makes the impossible feel inevitable. By the time real missions to Mars take place, they will carry not just tools, but centuries of dreams. What 3 Atlas added was urgency. If comets can bring ingredients, then the story of terraforming no longer belongs solely to human technology. It becomes part of a cosmic process, a conversation between worlds and wanderers. The comet reminded us that Mars is not just a static ball of rock, but part of a system still alive with exchanges of dust and gas. To think of terraforming is to join that conversation, to see ourselves not as conquerors imposing change, but as participants continuing what the universe began. The reality, of course, is slower, colder, and harder. Even optimistic studies suggest centuries of work, massive infrastructure, and energies beyond anything humanity has yet controlled. But the dream persists because it is not really about engineering. Terraforming in our minds is about hope, about refusing to see Mars as only barren. It is about insisting that the universe offers possibilities, even if they are distant. When 3 Atlas brushed past and then vanished, it left behind no atmosphere and no oceans, only a spark in imagination. That spark may prove more enduring than ice or dust. The comet reminded us that before we terraform planets, we terraform ideas. We reshape the way we think. We expand the range of what we consider possible, and we plant seeds in culture that may one day grow into action. Whether or not Mars ever becomes green and blue, it has already been remade in our minds, and sometimes that is the first step to making the impossible real. When people looked at 3 Atlas, they did not all see the same thing. To scientists, it was an interstellar comet, fragile, volatile, and curious in its chemistry. To dreamers, it was a message, a tool, or even a visitor with intent. To skeptics, it was proof of how quickly imagination fills the gaps. The comet itself was none of these things. It was only ice and dust, yet it became a mirror, reflecting back whatever each observer carried within. In this way, 3 Atlas acted like a cosmic Rorschach test, its shifting glow and vanishing act interpreted not as neutral events, but as symbols. The Rorschach test is a tool of psychology where ink blots are shown without meaning, and the subject projects their own thoughts and emotions onto them. The test reveals less about the ink and more about the mind of the person looking. 3 Atlas functioned in a similar way. Its hyperbolic orbit revealed nothing of intention, yet those who believed in cosmic breadcrumbs saw a trail. Its green glow was chemistry, but to others, it was life itself signaling across space. Its fading after perihelion was consistent with cometary fragility, yet many read it as concealment. Each interpretation revealed more about human nature than about the comet. Some saw hope. They imagined the comet as a seed, carrying the chemistry needed to one day wake Mars, to restore an atmosphere, to prepare the planet for life. For them, 3 Atlas was not random but purposeful, part of a larger process where the universe tends to barren worlds and makes them habitable. It was a story of care, of nature guiding life across the stars. Others saw fear. To them, the comet was a warning, a harbinger, or a hidden danger. Old myths of Nibiru re-emerged, tying the interstellar visitor to ideas of secret planets and cosmic catastrophes. Threads filled with talk of hidden civilizations and signals too advanced for us to recognize. These interpretations did not celebrate the comet, they trembled at its timing. The same green light that looked like promise to some looked like threat to others. And for still others, 3 Atlas was a stage for skepticism. They pointed to how quickly people turned a small body of ice into a canvas for their deepest hopes and fears. To them, the comet proved not that the universe was strange, but that human imagination is quick to find meaning where none exists. Their lesson was not about astronomy, but about psychology, about how humans always carry myth into the stars. This variety of reactions showed that ambiguity is fertile ground. When evidence is thin, people do not wait quietly. They fill the silence. A comet from another star is already rare, and rarity heightens the urge to explain. Each person draws from their culture, their beliefs, their fears, and their desires. The scientist brings models. The believer brings symbols. The skeptic brings caution. And the internet mixes all of them into a storm of competing stories. The comet becomes less a physical object than a shared test of interpretation. The cosmic Rorschach reminds us of a truth about exploration. When we look outward, we also look inward. Every strange discovery becomes a projection screen for human thought. Oumuamua did this with its odd shape and unexplained acceleration. Borisov did it by looking almost normal, but not quite. 3 Atlas did it by being too rich in carbon dioxide, too well timed with Mars, too quick to vanish. Each time, the universe handed us an ink blot, and we responded by writing ourselves upon it. This does not make the science less real. The orbit of 3 Atlas was measured, its chemistry recorded, its brightness logged. These facts will remain in archives long after the comet itself has faded into darkness. But layered upon those facts will always be the interpretations, the stories that turned a cold body of ice into a messenger or a warning. That layering is not failure, it is simply human. We are storytellers as much as observers, and the cosmos gives us the raw material for both. In the end, the test of the cosmic Rorschach was not about whether 3 Atlas was natural or artificial, dangerous or benevolent. The test was about us, about how we choose to see when faced with ambiguity. Some will always see gods, some will see equations, some will see both. The comet itself does not care. It has already moved on, carrying whatever truth it held into the endless dark. What remains is the reflection it left behind, the inkblot of its passage, and the many human stories drawn upon it. As 3 Atlas slipped away into the dark, fading beyond the reach of even the strongest telescopes, the sense grew that what it left behind was not data, but message. The comet had crossed the solar system quickly, arriving without warning, changing shape and brightness, brushing past Mars, then vanishing as though erasing its own trail. To scientists, it was a puzzle half solved. To storytellers, it was a symbol, and to the wider world, it became something more enduring, a reminder that the universe does not always speak in certainty. The last message of 3 Atlas was not written in words or signals, but in ambiguity itself. The comet's journey had been short in human terms, only months from its discovery to its disappearance. Yet, it carried the weight of ages. Formed in a distant star system, cast adrift by some forgotten force, it had wandered for millions of years before chance brought it near our sun. In that immense timescale, humanity's encounter was only a flicker, but in that flicker we filled it with meaning. We measured its orbit, we traced its gases, we debated its role, and then we argued about what it meant. The comet itself had no intention, yet we could not resist treating it as if it did. The last message then was not about what the comet was, but about how we responded. Some heard in its fading glow the whisper of panspermia, a suggestion that life is scattered freely across the galaxy. Some saw the terraformer hypothesis, imagining ancient engineers sending comets as tools to build atmospheres. Some resurrected myths, linking it to Nibiru or to sky gods. Others dismissed it, saying it was only another example of fragile ice collapsing under the heat of the sun. Each interpretation revealed less about the comet and more about us, about how humans meet the unknown with hope, with fear, and with imagination. When the orbiters around Mars finally returned their data, the results were subtle: small rises in carbon dioxide, faint clouds of dust, odd scattering near the poles. Nothing that proved anything, nothing that dismissed everything. Even in its passing, the comet refused to give us closure. This too was part of its message, that not every mystery bends quickly to certainty. The universe is not designed for our convenience. It does not always provide neat answers, and sometimes the greatest lesson is in learning to live with questions. For many, this was frustrating. People wanted resolution, a clear statement that the comet was ordinary or extraordinary, natural or engineered, a seed or a shard. Instead, what they received was a mirror. The silence of certainty forced them to confront their own need for meaning. The last message of 3 Atlas was that stories fill the gaps left by data, and those stories, even when unproven, can shape how we see the world. This is not weakness, it is humanity. For as long as we have looked at the stars, we have woven them into tales. Constellations are not patterns in the sky, they are patterns in our minds. Comets are not God's weapons or messengers, yet they became those things because humans needed them to be. 3 Atlas joined that lineage, becoming the latest object onto which we projected our fears and our hopes. Its message was not in its ice or its orbit, but in the fact that it reminded us of this ancient practice, that we still write ourselves into the sky. As it drifted back into the void between stars, the comet carried no voice, but we gave it one. We said it whispered about lost civilizations, about cosmic trails of breadcrumbs, about the fragility of knowledge in a vast and silent universe. Perhaps in the end, That is the only message any interstellar visitor can leave. Not instruction, but inspiration. Not answers, but questions. 3 Atlas told us nothing directly, yet in trying to interpret it, we revealed much about ourselves, our hunger to know, our struggle with ambiguity, and our refusal to stop imagining. The last message of 3 Atlas, then, is this, that the universe is both silent and speaking, empty yet full, chaotic yet filled with stories. It reminds us that science and storytelling will always meet at the edge of the unknown, and that every comet, every signal, every faint flicker of light is an invitation to wonder. We may never know what 3 Atlas truly was, but in wondering, we carry forward the most important message of all, that curiosity itself is the fire that keeps us searching.